Welcome viewers. In this video we'll see the details about three-phase alternator. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Introduction about three-phase alternator, also called a synchronous generator or AC generator. Now we'll see the introduction. An electrical machine which converts mechanical energy into electrical energy in the form of three-phase alternating current and alternating voltage is called an alternator. So it converts mechanical energy into electrical energy. Almost all the generator will convert mechanical to electrical. Here we are having three-phase alternating current and voltage. So it is also called a alternator, AC generator or synchronous generator. They are also called synchronous generator because their speed is fixed by the frequency and number of poles. So during the construction itself, the number of poles is fixed and the supply frequency also fixed. So it will rotate in a synchronous speed. They are also called as AC generator. In an alternator, the armature winding is placed in the stator, stationary part, and field winding is placed in the rotor, rotating part. Just it is opposite of the DC generator, DC machine, right? So armature winding is placed in stator, field winding is placed in rotor, rotating part. Now we'll see the majorly two types of alternators available. We'll see this one by one. Alternator may either have revolving armature and stationary field. Field is stationary and armature is revolving. One type. Second type, revolving field and stationary armature. So both the case having lot of advantages. So we can use two methods. First we will see the revolving armature and stationary field. So it has a stationary field winding and revolving armature. It is used for small kVA capacity and low voltage rating alternators, right? So the stationary field and revolving armature is used for low rated alternators, right? The alternator construction and operation separate video available. This is only about introduction. Now we'll see the next type. So second type is revolving field and stationary armature. It has stationary armature and rotating field poles. Most alternator are of revolving field type. Almost commonly we are using revolving field type. Armature winding is placed on stator and field winding is placed on rotor. That we already discussed. Now we'll see the further detail. The field winding, to the field winding, the DC supply is given from a DC source, which may be either DC generator which is mounted on the same shaft as that of alternator. So for the field winding, DC supply is given, that is from the DC generator. This generator and alternator are coupled together in the same shaft. But since the field windings are rotating, the DC supply is given to the field winding by means of slip ring and brush assembly, as very similar to the DC motor, DC machine. So rotating part, so it is given through the slip rings and brush assembly. Now the rotating field winding produces a flux which is being cut by the stationary armature winding. Hence EMF is being induced in the armature winding, right? So the rotating field winding, that will produce a flux. So already the stationary armature winding is there, so that is cut by the stationary armature winding. So the EMF is induced. This is normal, the electromagnetic induction principle. So these advantages of this revolving field. Output can be directly taken from fixed terminal on stator with the brush contacts. So easily we can take the output. Easy to insulate stationary armature winding for a high AC voltage, because armature is stationary, so we can easily insulate for high voltage application also we can easily insulate. Slip rings are transfer to the low voltage, low power DC field circuit, which can be easily insulated, right? So we are using brush assembly and slip ring, but that is for only low power, so that also easily can be insulated. The armature winding can be more easily braced to prevent any deformation which could be produced by mechanical stresses set up as a result of short circuit and high centrifugal forces. So the armature winding can be easily prevented from the mechanical stress and other forces. These are all the advantages of the revolving field. So in this video we discuss the introduction about alternator, that is synchronous generator or AC generator. So we have stationary part and rotating part, armature and field. Here there are two types available: revolving armature, stationary field, or stationary armature and revolving field. So these two types that we discuss, and our advantages also we discuss. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination.